All right. Today we're going to simplify things to see if we could get even the simple thing working. So here's what I'm going to do. I'm going to pass in just a single coil. And we're going to see if we could get the reconstruction working with just one coil. I guess we'll just run this. "477, there's a bug. Should I put a to-do for myself? Should only subtract B when projecting. Right. Okay. So this was in the prox DC indicator. Ooh. Okay. So that was a bug that has nothing to do with the single coil. And let's see what, now can we run it? All right. Two minutes down. Time flies so amazingly fast. Okay, so that's still not good. It's still just the low, the low frequency estimate, the least squares estimate. Here's what I'm thinking. If CS is true, if we're using one coil, well, if the noise variance is 0, right? If the noise variance is greater than 0, then we would do this. If the noise variance equals 0, noise variance, I'm sure I've checked to make sure that it's positive. Yeah, is non-negative. Okay, so it's either 0 or greater than 0. If it's greater than 0, then we do what we've been saying. But if it's equal to 0, then the problem becomes much simpler, because then what we want to do is minimize the wavelet transform or the sparsifying transformation of the reconstructed image. What's the reconstructed image? It's F inverse K plus K data. So here, this K is M transpose K unknown. That's equivalent to so the improvement is that the number of unknowns is reduced because the K data don't change. They're fixed when the noise variance is 0. I'm going to add an inverse option. To apply F. Okay, so down here, this is apply A. We're going to take M, we need to do a concat again. Concat psi F inv MT. No, compose. So the first thing we're going to do is apply M transp. Then we're going to do the inverse. I don't think I can do this. Where's apply F? I guess I can make the inverse transp. IFFT2H, nice. I've worked on this before. Should it be inverse transp or transp inverse? It's the transposition of the inverse, so I'm going with transp inv. So that should just be inverse, shouldn't it? Now this one's going to be out is equal to apply M no transp. Guess I could get rid of that to avoid the string comparison. Apply F inv transp inverse. Apply or psi in transp. Let's add it to do checks. behind an if statement if W size. Okay, let's take it out of there. Put it here, I guess. Right, so now this is just NB1. NB1. No, not NB. N samples minus NB. The number of unknowns. NB is the number of knowns. N is empty. And samples? They're the same. NB is the number of samples. S out. What is that? Still have different number of elements. Oh. This isn't M. This is M complement. We need the transpose of M complement, not M. Needed that. It passed. Okay. So now we have apply A, which is this matrix. So prox G is equal to at in T. First, let's come up with G. So prox G is equal to, or G is equal to at in norm I need the, oh, sorry, okay. GCS, I'm gonna need another GCS. Not GCS multi-coil. But now this is gonna be plus this B thing that we've got going on here. Psi F inverse K data. Psi apply F inverse K data. ECS is equal to huh. Nano's really going down. Okay. Now we need prox GCS. Prox L1 complex NT plus BCS minus BCS. Okay. So now we're doing this minimization. This is the simplest form of compressed sensing. It's hard data consistency. This is wrong. This was wrong. How did that even work? Norm A is still about the same. What is image 0 at this point? 256 by 256. How does that work? Oh, I see. Am I passing in a noise variance greater than 0? Okay. Apply F inverse doesn't exist? Because I did it the other way? Yeah. Right. Because now this is the wrong size. Instead of image naught here, I'm going to say x naught. And we're going to have to set x naught here. It's very different now. The norm of applied A is very different now. It doesn't take any time, so we're to make a mistake by loading the old apply A, so we're just going to set it to that. Okay. We're in PDHG. We're just going to try running it and see what happens. Nothing's running. Unrecognized function or variable GCS. Apply A. Now we go into G. GCS. Okay. Okay. Why isn't GCS defined? Seems like I'm defining it right there. What does that mean? Unrecognized function or variable? Oh, you know why? Because I know the answer. GCS is already a function handle. So when we set G, we just need to set it equal to GCS, not at GCS. How about prox GCS? Prox GCS is also a function handle. Okay, there we go. Too many input arguments. Have I not been? I just realized That was super silly. I have not been sharing my screen. You guys have just been staring at me this whole time. Ay, ay, ay. Okay. I guess that's not the issue, is it? Is it? It's well, that's definitely going to happen, right? Else. So here, image is going to equal apply F inverse, apply MC transp. Since y'all weren't seeing me, I guess I got to recap a little bit. I created this. If the noise variance is equal to 0, then this is apply A, just psi F inverse MCT. CS is not equal to true? What? Oh, goodness. I have broken so much trying to get this implemented. We'll worry about this some other time. Are we finally going to get here? Unrecognized function of variable transp. Oh, and there's no apply F inverse. There's only apply F inverse. That is a terrible result. I just can't help thinking it's in prox L1 conjugate. Or should it be like this? I can put a B right there, so there's a minus B. I could just do it here. In thresh weights B. In thresh weights BCS. But this isn't hard, right? So I should be able to figure this out. If you subtract something from the inputs, then when you're doing the proximal operator, you want to subtract it from the input, do the proximal operator, subtract it from the output. Does that make sense? So if I'm doing soft thresholding around B, and x is equal to B, I'm going to take x minus B minus B, that's 0. All this will be treated as though it were 0, and then I add B. Okay. Is this what I was doing? Or was I doing that? It clearly needs to be that, right? If we're adding B, and so x is equal to minus B, well, I can change something dramatically and it doesn't change the results. If A is 1, we're adding B. We add B on the inside and subtract it on the outside. We're adding B. We add B on the inside and subtract it on the outside. Okay, that seems like the answer, doesn't it? That's the wavelet transform. Right, so we're going to take the wavelet transform of the data. We're going to take the inverse Fourier transform and the wavelet transform of the data. We're going to add that to the wavelet transform of the uncollected values, and we're going to add that to the wavelet transform of the data. This would be the wavelet transform of the reconstructed image, and we want to minimize the L1 norm of that. All of that makes sense. Oh, it's just K unknown. For the reconstructed image, K unknown is equal to the image. This image is just what comes out here. Actually, for our case, what comes out here is just K unknown. So we need to change the variable of this if we ever get this working. And so this is going to be apply MC K unknown plus K data. Okay. That looks like a compressed sensing reconstruction. we have the wavelet artifacts, and they're extreme because we're requiring all the data to be fixed. And it's very undersampled. I think we have this working. Let's go and do our thing. So we're going to call this Y. Y. Y and Y. Isn't this always a feasible problem the way that we're doing this? I think it is. Okay, so this is working when we got something working. We got some version of compressed sensing working. That's what we're going to do today. What am I doing? So we created we altered apply F so that you could supply no transpose or transp like before. We can also now supply inverse and transp of the inverse, which is good. Now we've got psi F inverse. We made this function, psi F inverse, which applies psi, apply F, and MC transpose. And this gets used. We checked its adjoint, and this is the problem that we're solving. Minimize the L1 norm of psi times F inverse times MC transpose times K unknown plus K data. We sent that through PDHD, and it came out with a good answer. So G is equal to the L1 norm of in plus psi F inverse K data. And the prox of G is just the prox of that operator, of that function. So it's soft thresholding with a plus on the inside and a subtraction on the out. What's the big difference between this one and this one? The indicator function. Since this works, it suggests that the error is in the indicator function or the proximal indicator function of this. We could just set BCS here to 0 and then just call these two. But that's all right. That's all right. Look, it's clear, right? If BCS were 0, it would be the prox L1 complex of in. That's it, prox L1 complex of in. GCS would be norm of in 1, norm of in 1. So certainly looking like the problem's in the indicator function. It's my best guess right now. There are probably so many things broken about this code. Like probably SPIRiT regularization doesn't work at all anymore. Fine, we'll worry about that later. Okay? We got something working, which we haven't done in a long time, and that feels good. I'll see you guys next time.